Assalamu alaikum. Today we shall discuss about discrete probability distribution and the learning outcomes that after this recording you will be able to calculate and interpret the expected value of a probability distribution. You will be able to apply the binomial distribution to applied real life problems, and then you will be able to recognize when to apply the discrete probability distributions. Random variable is a variable which can take different numerical values based on chance. It represents any possible value which occurs as a result of just a random event. Random variable can be of two types. The one type is a discrete random variable, while the second type is the continuous random variable. Their graphs look like this. That discrete random variable has a frequency distribution like these bars, while continuous random variable has a distribution like this curve. Now, the further explanation about the first type of random variable, which is discrete. A discrete random variable is a variable that can assume only a countable number of values. It can have more than two possible outcomes and it can have only two possible outcomes. For example, number of complaints per day is an example of discrete random variable because it can only assume countable number of values. Number of complaint cannot be 5.25 or 3.24569. It will be either 3 or 5. So, absolute values, no values in the decimal. So, that variable is known as discrete random variables. Other examples of discrete variable having more than two outcomes are number of TVs in a household, number of rings before the phone is answered. All these variables have more than two outcomes. And the second type of discrete random variable is a variable which can take only two values. For example, male or female, a product may be defective or it may not be defective. Spreads peanut butter fast versus spreads jelly fast. So, these are only two outcomes. So, discrete random variable can have more than two outcomes as well as it can have less than it can have equal to two outcomes. However, it cannot take any value which is in the decimals. Now, the second type is continuous random variable. Continuous random variable is a variable that can assume any value on a continuum. What does it mean? That it can take values in decimals as well. The examples are thickness of an item, time required to complete a task, temperature of a solution, height in inches. For example, height of a student can be 52.2439 inches. So, just depending upon the accuracy of the measure used, all these variables can have any values on a continuum. Or you can remember that a variable which can take the value in decimal is called continuous random variable, and a variable which does not take the value in decimal is called discrete variable. Now, about discrete variable, this is one example of a dice. If we roll our dice twice, either we can have 0, 4, one time 4, or both times we can get 4. These are the 6 possible outcomes of a dice. Now, another example is toss a coin 5 times. So, if we toss a coin 5 times and if x is the number of heads and we toss a coin 5 times, the possible outcome or successes are that we may get 0 head, 1 head, 2 head, 3 head, 4 head, or we may get head all the 5 times. Now, this is very easy example of discrete probability distribution. In this example, we toss 2 coins and we put x is equal to number of heads. You know that coin has two sides. One side is known as head and the second side is known as tail. So if we toss coin 2 times, these are the 4 possible outcomes. The first is that both time we get tail, so 0 head. The second outcome is the first time tail, second time head, so 1 head. Third possible outcome is first time head, second time tail, so again 1 head. And the fourth possible outcome is that we do not get tail, we get head both times. So the x value, which is success, can be 0 head, 1 head or 2 head if we toss a coin 2 times. Now to find out the probability that there will be 0 head in 2 coins or 1 head or 2 coins or 2 head in 2 coins, we will see then in how many outcomes we are having 0 head. So out of 4 possible outcomes, there is only one outcome where we have 0 head. This probability will be 1 over 4. And out of 4 outcomes, there are 2 outcomes in which we have 1 head, the second one and the third one. So the probability of 1 head will be 2 divided by 4 is equal to 0.5, and the probability of getting the head both times, 1 is the outcome, the last one, and total number of outcomes are 4. So 1 divided by 4 is equal to 0.25. Now if we add these all probabilities, their sum will be equal to 1. So we just we should remember this thing, that sum of probabilities will always be equal to 1. Now these are some characteristics of discrete probability distribution, that if x is value of random variable outcome and p is its the probability, x outcomes are mutually exclusive, there is no overlap, and they are collectively exhaustive, nothing left out. These two important rules we should remember here, that value of the probability lies between 0 and 1 inclusive, which means that it can be greater than or equal to 0 and it can be less than or equal to 1. However, if we sum the probability of all the outcomes, that will be equal to 1. The sum of all probability will always be equal to 1. If we want to find out the mean of a probability distribution, we will simply call it expected x. Expected s is the expected value or mean of a probability distribution. That is the sum of x multiplied with its probability. So here, like arithmetic mean, we shall not divide it by n, we shall simply multiply the output with its probability. Now here we have the example. If we toss a coin 2 times, or if we toss 2 coins and x is number of heads, we know that the possible number of heads in 2 coins can be 0 head, 1 head or both time head, and their probability are 0.25, 0.50, 0.25, which we just explained in the last slides. If we need to find out the expected value of x, we will simply multiply these x with their relevant corresponding probability. So 0 multiplied by 0.25 here, plus 1 multiplied by 0.50 here, plus 2 multiplied by 0.25, we add them together, we get the answer 1. So 1 is the expected number of head if we toss 2 coins, or if we toss a coin 2 times. So this is how we find out the expected value of a discrete probability distribution. The second is the standard deviation, and the standard deviation, again we take the deviation of x from its mean, we take its square, and then instead of dividing it by n, we multiply it with the probability of x, then we take the square root and we find out the standard deviation. In the same example which we solved in last slides, we know that if expected outcome is 1, so 0 minus 1, 1 minus 1, 2 minus 1, we take their square, multiply it with their corresponding probabilities, and we do not divide it by n or n minus 1, we simply take the square root and we conclude that 0.707 is the standard deviation. of number of heads if we toss 2 coins. Here we will see that probability distribution may may be discrete probability distribution, and it may be continuous probability distribution. Discrete probability distribution has further 3 types: binomial, Poisson, and hypergeometric. Now we shall discuss the first type, which is binomial distribution. In the binomial distribution, we have only 2 possible outcomes. N is a number of identical trials, and all the trials are independent of each other. Probability of success remains constant from trial to trial. We denote it by P, and if we take 1 minus P, then it is equal to Q. So, P plus Q will be equal to 1. Some examples of binomial distribution: manufacturing plant labels items as either defective or acceptable. Firm bidding for a contract will either get the contract or not. So, all these outcomes, all these examples have only 2 outcomes. For example, product is defective or acceptable, yes I will buy, or no I will not buy. So, if the number of possible outcomes are only 2, like gender, male or female, smoker or non-smoker, we call it binomial distribution if number of outcomes are only 2. Now, to find out the probability of success in a binomial distribution, first of all we need to know the counting rule. Counting rule for combination is n factorial divided by x factorial multiplied by n minus x factorial, where n is the total number of possible trials and x is the number of successes. This is the formula to find out the probability. Here we put the combinations, which is n factorial divided by x factorial into n minus x factorial. We multiplied it with p raised to power x time q raised to power n minus x, where p is the probability of success and q is the probability of failure. With the same example, if we flip a coin 5 times and x is number of heads, so n will be 5, and if we want to find, and probability will be 0.5, because coin has either head or it has either tail. So, probability of head is tail, probability of head is 0.5, probability of getting tail is 0.5. So, p and q both are 0.5. So, x can be 0, 1, 2, 3, 4. These are the possible outcomes. To find out the expected value of a binomial distribution, we simply multiply the n with its probability, and to find out the variance and standard deviation, we multiply 3 things: n, p, q, and then we take its square root and we get the standard deviation. So, this slide explains the expected value and variance and standard deviation of binomial distribution. Here are some, it has been solved with the help of examples. It's very easy. N into p, so n is 5, probability is 0.1 or 10%. So, expected value will be 0.5, and then we multiply it n into p into q. So, n is 5, 0.1, 1.1, so we will get 0.6708. This is example of binomial distribution. 35% of voters support proposition. If a random sample is of 10 voters is polled, what is the probability that exactly 3 of them support the proposition? So, here n is equal to 10. Probability of x we have to find out, where x is equal to 3. So, we will put this value in this formula of binomial distribution. N is 10, so 10 factorial. 10 factorial means 10 multiplied by 9 multiplied by 8 and so on till 1. Then divided by x factorial, so 3 factorial into 7 factorial into 0.35, which is the probability. P value raised to power x, which is 3, multiplied by q, 0.65 has been obtained by 1 minus 0.35 raised to power n minus x. So, 10 minus it is equal to 7. When we solve this, we get 0.2522. So, we shall say that there is 25.22% probability and that 3 pupils selected randomly will support the proposition. So, we can also find out these value from the table here. If p is equal to 0.35, n is equal to 10, x is equal to 3, p is 0.252.